Alright, so this next little demo, we're going to create a game that's sort of like Space Invaders. So we'll have some objects moving back and forth on the screen going from left to right, and then we'll have a little guy on the bottom that we can control and have him shoot missiles at these things as they move left and right. So we'll work on kind of coordinating the movement and handling some collisions, and we'll also play some animations and work on giving some objects some kind of autonomous properties. Like when we shoot the missile, it's going to be able to take off on its own. So we'll create a new project, and we will call this, I don't know, Space Invaders 2000. And we want to make it a 2D game. And so this thing right here is actually a button you can click on. It looks just like words, but we'll click on it and make it 2D. This is obviously a button because it has a rectangle going around it, and this here is obviously a button because it has a rectangle going around. These things are not obvious that they're buttons. So yeah, just click on the 2D here. This thing is actually something you click on. So click on it, and then we will create our project, and we will end up with Space Invaders 2000. We're going to be using some Glitch the Game assets on this one. So if you have those things downloaded, look through the FLAs, try to find these assets that we're going to be using. Let's see, let me drag those things in. Let's see. So we have, let's grab all of this stuff and drag it in, and I will show you what we've got here. So we've got a bunch of things here. We've got our little bureaucrat guy, he's going to be walking around on the bottom. I don't really remember which one of these I want to use. Guess it doesn't really matter. Our crafty bot is going to be the thing that's walking back and forth. This is another guy. Actually, you know what? I'm just going to delete these two. Sorry. I dragged in a bunch of stuff from a different folder. So we'll use these crafty bots. I'll show you what they are. This guy, it's going to be an animation when we get through with it. We already did animations in the other one, so if you need a refresher on animations and sprite sheets and that sort of stuff, you can go check that one out. We'll go through it in here, but might go kind of quick. And let's see, here's this thing. This is the guy that we're going to be controlling. We'll move him around. And this is going to be the thing that we shoot. And then this star here is going to be like an explosion animation. We'll just kind of fade it out, twist it around, and play it in the spot where the collision takes place. And that's going to be our wonderful game. So before we get too far, I'm going to change this camera, make it all black, and let's start working on our player controller. So this thing here, again, it's a sprite sheet. So we need to change this to multiple, go to our sprite editor, and slice it up, and hopefully we will get it perfect, which it does. So we'll apply, and now we've got this nice little frog guy that I can drag out here, and we will just call this thing a player. And if we run, what does it do? His hat spins, and that's good. So that will be our player. Maybe we'll scale this thing up just a little bit. And let's see. So we're going to need, I'll make a folder, we'll call it scripts. Oops. And inside of here, we will create a C# script called player controller. And we will attach it to our player, this, and we will edit it inside of MonoDevelop. So again, this thing is just going to move our player left and right. We're not going to move them up and down or any of that sort of stuff. We want to go left and right and then shoot. So we will have a public float horizontal speed. And I can't remember what that was, 1, something like that. I don't know, we can change it later. And then inside of our update, we're going to get our key presses. So we will say if input get key key code left arrow, and we'll move left. If we have the other one, we will move right. So if it's a right arrow, we will move right. And if it's the space, we will shoot. And yeah, I'm going through this kind of fast, but that's okay. And we're going to say get key down because, you know, just because of how we want to make this game, we don't want to have the person be able to just hold down the space bar and shoot a whole bunch of times. We want him to actually have to click the space bar every time he wants to shoot a missile. So now we'll create our functions. And inside of this, we will get our position. Oops. And remember, this is attached to our player. So when we say transform.position, we're getting the position of the player. And we will say position.x plus equals horizontal speed. And transform.position equals position. And we're done with that. Oop, that's move left. So we don't want to add it, right? Because this is going to make him move to the right. So we'll subtract it. That'll make him move left. And right will be the other way. And that'll just be a plus. And then we have shoot. And inside of here, we will just say log. Okay, so this is, we'll get to this shoot eventually, but for now we'll just stub it in, and this is how we're going to go. So hopefully if this works, our little guy will move. Let's see what happens. Whoa, way fast. Okay, that's all right. Let's change his speed. Since we made it public, remember, since this thing here is public, we can change the speed over here, and let's just make it a 0.1. How's that? Oops. And I'm going to save my scene, because I haven't done that yet. I don't really care what the name is. All right, here we go. That looks a little better. So now left arrow, right arrow, moving. Every time I hit the space bar, it says shoot. Oops. And we can see this counter going up every time I hit the button, which is good. That's what should be happening. So we have our guy going back that we can control. Now we want to give him something to shoot at. So let's take a look at our crafty bot, and let's slice this thing up, make him a multiple, and slice. We get it? Yep. And apply that. There we go. And now let's drag our crafty bot into the scene, and if we run, there we go. He's doing his little animation, and that looks great. But the idea that we want to have right now is we want him to go all the way from the left to the right and just go back and forth and back and forth and back and forth. And so we'll just stick him over here. And we want him to walk all the way over here and then turn around and come back. And then we'll, give our little frog guy a chance to shoot him. So let's do that. And we will just call this, what are we going to call this? Robot. Something real original like robot. All right, and so we are going to have a robot controller script. And we'll attach that to our robot. Just drag it over. And let's edit it. And now the robot controller is going to be very similar to the player controller, right? We know initially, so we can start just copy and pasting code because it's a lot easier to do that. Initially, he just needs to move left. And then there's going to be some condition that happens, and then he needs to move right. And then he's got to move left, and then he's got to move right. And so that's what we're going to have happen. So we're going to need move left and move right out of here. Let's just bring it over. Because, we can sort of just copy and paste this code because we're referring to transform, and that is referring to the object this script is attached to. So now that robot controller is attached to a robot, then this is what's going to happen. All right. We need a couple more things out of our player controller, like how about speed, make that public, and I'm just going to put a 0.1 in there, 0.2. And again, that's going to be the default. We can override that if we want to. And let's put in a direction. And this is going to represent, you know what, I don't want to do this. Let's get rid of this move left, move right business. We'll leave it in. You'll see that there's probably a much simpler way to do this, but we'll leave it in like this just for consistency. Okay, so direction is going to indicate which way we're going. We'll say it's a -1 if we're going left, and a +1 if we're going right. And since we're starting this guy way over here, we're going to want him to go, left initially. So we'll say our direction is -1. So inside of our update, we can say if direction equals -1, we'll move left, else move right. And some of you guys are new to programming. I've got my curly braces here. If you only have one statement, you don't really need your curly braces, but it's always best to just stick them in anyways. That way it'll always sort of separate the code and say that, this move right is part of this else block. So let's see what happens. I mean, this thing is probably just going to work, right? If we run, there he goes. And he keeps going. So at some point, he's going to get over here, and we want him to turn around and go back the other way. And so let's see. We can do this a couple of different ways. Right now, we've got our robot selected, and he's at position 8 on the X. If I want to see him go all the way over here, I can see that once he gets, let's just say, to -8, and I'm watching this number up here. When he gets to roughly -8, we want him to turn around and go back this way. So let's make his range between 8 and -8. So if he's moving to the left, right here, we say move left, we update our position. We can say something like, we'll make float left side equals -8f, and public float right side equals 8f. And again, these are just numbers that I came up with by dragging this guy across. And now we see that -8 and 8 are here. We made them public, so later on we can adjust them if we want to. But for now, we'll just leave it there. So if we're moving left, if we say something like if position.x is less than left side, then we will say direction equals 1. We want to go to the right. And same thing with this. If direction.x is greater than the right side, then direction equals -1. All right, so does that work? There he goes. Bink, bink, bink. And now he's just going to go back and forth forever. And, we still have control over my little guy here. Eventually, we're going to give him a bullet to shoot. But right now, our little robot guy is going back and forth. He's kind of, it looks a little bit weird because he's kind of moonwalking backwards and then going forwards and then moonwalking backwards. It'd look a little bit better if we could have him face, to the right as he's moving this way. And that's actually really simple to do because really all we want to do is we've got this guy here, and when he's moving to the right, we want to just change the scale so that it's a -1. Now he's facing to the right, and then when he's facing left, it's just a scale of 1 on the X scale. And you can flip things in the Y-axis too. Just go this way, and now you have he's upside down. And so these are like little tricks that you can do to make it look like you've got more graphics, or that these graphics are doing more things than they actually are. So let's take a look at that. So here we go right here. We're going to change directions. And so this is, we're moving left. Now we're going to move right. And so we're going to say that vector 3 scale equals transform dot local scale. And we will say scale dot x times equals -1. We're just going to flip it. And then we'll say transform dot local scale equals scale. And then we also need to flip it when it goes the other way as well. So I'll just copy and paste. And let's see what happens. I wonder if this will work. There he goes. Now he's facing the other way. And this will keep updating over and over and over and over and over again. So pretty cool. You know, a couple lines of code, we make it look a lot better. And you can think about these little tweaks you want to do as you're putting your code together. And small things like this can really make a big difference in the appearance of your game. I still don't like this animation that much because he's kind of floating, but then again, he really is sort of in outer space, so maybe it's okay. Maybe we don't need an animation of his feet going, but anyways, at least he's going back and forth. And you know, my controls still work because the checking the keyboard is done on the thing that's attached to on the script that's attached to the player, and there is no get keyboard in the robot controller script, and so that's just all going on its own. And then the player controller, this is where we do all this get key business. All right, and we can even do something more like, let's see, let's make this guy a prefab. How's that? Make a prefabs folder, and in here, let's drag our robot down, and we can copy him. And copy him, and there we go. All right, there they go. And they're all sort of in their unique little space, which is really neat. All right, so how about if we do something else? Let's make another robot. Actually, let's just drag these robots up. Like this. And let's see what happens. So this is a little bit different than how Space Invaders works. When Space Invaders works, they're all either going to the left or they're all ever going to the right. This little follow the leader thing doesn't happen. And so we need to change that so that they all turn essentially at the same time. And so if we look at our script, right now we are saying that we're determining move left, move right, our direction is based when an individual robot makes it to the side. And we don't want it to be like that. We want it to be when any robot makes it to any side, we all need to change directions. So what we're going to do is we will create an extra empty game object out here that's called, what should we call it? Group enemy controller. How about enemy controller? Create empty. We will call it enemy controller. And this thing is going to be responsible for telling each of these robots what direction they're going. And then that way they will know we can have them turn in unison, as opposed to this follow the leader thing where they're all kind of passing behind one another. That looks really strange. So in our scripts, let's make an enemy controller script. And we will place that on our enemy controller object. And let's see, let's open this guy up. So what does this thing need? Well, the first thing we need to know is we can say, let's just say private direction equals -1. So we'll start off going left. And then how about we'll add a method that says public int get direction. And we will return direction. All right. And so now, if any of these robots can access this enemy controller script, they'll all be accessing the same direction variable, which means no matter what this thing is, they'll all be going the same way. When this thing flips from a -1 to a 1, they'll all turn at the same time. So we can also have a public void flip direction. And inside of here, we will say direction times equals -1. And there we go. Now, inside of our robot controller, we need to somehow get a reference to this enemy controller. So let's make a private enemy controller. We'll call it enemy controller. And in our start method, we need to find where that thing is. So we could go through and assign it in each of our, oops, I'm in the wrong thing. Sorry about that. This enemy controller is going to be a member of our robot controller. Right. So now we could go assign this to every robot in the GUI, but I think we'll just do a find inside of here. So we can say enemy controller equals game object dot find enemy controller dot get component, and it's of type enemy controller, like that. All right, so again, this long string, we did this before. So we're doing a game object find by the name of it, which is a little bit expensive. So you don't want to do this kind of stuff inside of update because it's got to go through all the objects in your scene. Doing it once during start really isn't that big a deal. I mean, I guess it really does depend on how often you're doing this sort of thing and how many objects are in your scene. But for our little example here, it's not going to matter. But so we say game object find enemy controller. This first piece here is looking for an object name over here on the side, and then the second piece, get component enemy controller, is looking for something over here on the right, an object or a script that's attached to that object, a class that's attached to that object. And so now it's getting this component here of enemy controller, and that's going to allow us to get access to this script. All right, so I'm going to get rid of direction. And we will say if enemy controller dot get direction. So anywhere I have direction, I want to change it to this because it's going to get the global direction. And let's see. So here we're doing some flipping of the direction. So instead of this, I will just say enemy controller flip direction, right? And we'll do it down here too. And let's see, is that going to work? Probably not, because it's going to work for the very first robot that we have, right? Because he's going to come down here and say, oh man, I'm at the left side. I'm going to call the enemy controller flip direction method, which right here is just changing our direction, which is exactly what we had before. He's going to face the other direction, which is right, and then, I'm sorry, correct and right, and move on with his life. The other guys, the guys who are in line, like this guy, for example, his direction is going to change because he's always getting direction from this global setting, but he's never going to face the other direction. You see that? Because the only guy whose code is going to act, this code's going to get executed, is the guy who's in charge of flipping the whole thing. So let's just run this thing and see what happens. So see how this guy is the only one facing. See, his direction is facing. It's getting a little bit confusing now as far as what's happening. So what we really need to do though is we'll just add a little bit of code. This is fine here. But the other thing we can add is we need to know what our last direction was. Let's see, what's going to be the best way to do this? Let's not do this here. Let's make a method and call it void flip object. And we'll put that code in there. We'll delete it out of these places. And so now they're never going to move. I mean, they'll always just be facing the same way and bounce back and forth. All right. And what we want to do is we have this flip object method right now, and if we call this, it would change the way they're facing. But we need to figure out when to do that. So we come into this thing, and I can say something like, let's say inside of start, we'll say last direction. So this int is gonna hold the direction we were facing the last time we came through the update loop. And so first we need to initialize that. So we'll say last direction equals enemy controller dot get direction. And then when we come in here, we can say something like int new direction. How about current? Equals this. Let's pull this thing out of here. That way, so we could keep checking for this over and over again, but every time you check for it, it has a chance of changing. And so I'm going to just set it to a variable that's local to this update method. That way it's going to be consistent throughout our function. And we can do this, current direction. Like that. So now we have our current direction, which is this, and we have our last direction, which we set up here. And down here, when we leave our update functions, I'll say last direction equals current direction. So that's going to save it for the next time. And then right here, we can say something like if current direction is not equal to last direction, then we need to flip our object. All right, so I hope that made sense. Kind of feel like I was rambling through that a little bit, but so when we come through update, we're going to get the current direction out of our enemy controller. This is the way that we're supposed to move this update cycle. If the current direction is not equal to the last direction, we're going to flip our object, flip the way it's facing, and then we'll continue on with our moving. Then we get down here, and our last direction equals our current direction. So the next time through, we're not going to keep flipping. And then as soon as we realize that there's been a change, we will, essentially set this flag that says we're different, this thing, so that we can flip ourselves and continue on. So I think this will probably work. We'll see. There we go. Perfect. So there isn't, it's not exactly perfect because you notice these distances were getting off a little bit each time. And that has to do with when we decide to change direction, some of the sprites during that update sequence have already moved on, and then some of them haven't. And so essentially what you have is some that are changing direction before others, which is putting this gap in there. So we could fix that. I'm not going to. If you want to fix that and are having issues with it, please let me know. We can walk through it. But for this case, I'm not going to do this. So essentially what you have to make sure is that each sprite has had the same number of update steps when it's time to change the direction. And if it has not had the same amount of update steps as the leader of the pack, then you have to make sure that it does get that many before it's time to change direction, and that'll fix it. But I don't want to go into all of those details for this thing right now. All right, so this is exciting, right? We've got, let me get back to this. We've got this thing going here. We've got our guy going back and forth, and I can hit the spacebar to shoot, and nothing's happening. So what we're going to add right now is a missile that's going to come up from this guy's head and shoot something. In order to do that, we need to have a missile, which we do. And the way this works is we want to create an object that's just going to fly up. That's the whole purpose of this object, is to fly up and then try to crash into some of these robots. And we're going to create a prefab that's based on this still here, we'll call it a missile, and it's going to have a script associated with it and some box colliders so that it can detect that it's crashing into this thing. And then when we hit the spacebar, then this thing will just get created. It's going to know that it's supposed to be going up, and it'll just go. So maybe that didn't make any sense, and actually I'm pretty sure it probably didn't make a whole lot of sense. But as we go through this, I hope that it will make more sense. So let's put this still out here and create the behaviors that we want to have. So this still is going to be created from our little guy here. I'm going to shrink it down just a tad bit. It's going to go up. Let's call this bullets. How about missile? That sounds more official. And we'll create a missile prefab. And then let's go to scripts and create a missile controller. And we will assign it to our missile here. And let's see, what else is this thing? Let's give this guy a box collider, physics 2D, box collider 2D. So this thing, this box collider that I created is way bigger than our little still here. Oops, I don't want to do that. So we want to shrink down the box collider like this. Let's give it a little bit of an offset. Our Y's need to get smaller. That. Let's see, make our X just a little bit bigger. There we go. That's going to be probably close enough. So here is the edges of our collider for this thing, and we have our missile controller script. Essentially, what we want this thing to do is, right? Let's just save it. Who knows what was in there? Well, I have no idea what we just saved, so hopefully things still work. Let's check it out and see. Did things still run? Yeah. Yep, who knows? Probably just a little typo thing. So let's work on our missile controller again. So the whole purpose of this thing is to just cruise up. It's just supposed to go in the up direction. So let's give it some speed. Float, vertical. And let's just say 1F. How about 0.5? And then every update loop, we are going to just move it up. So we'll say vector 2 position equals transform dot position, and position plus equals vertical speed, and transform dot position equals position. And if we save that and run, let's see what happens. Oh, errors, plus equal position dot y. How's that sound? Much better. Let's see what happens. Okay, there it goes. It went. Let's see, is it going to go again? There it goes. It's a little fast. Let's just change this to a 0.2 so we can see it. And I'll apply it so that gets set to all the prefabs of this missile. There it goes. And notice, here's our missile. It's still cruising. Y50, it's out there in the middle of nowhere. And that's not very good, because that means anytime we shoot a missile and we actually get to wiring this thing up to the spacebar, once they go off the screen, they're going to just keep going forever. So we need to clean this code up a little bit. Once this missile goes above this screen, we want to delete it. So let's watch our Y position here, about maybe 10 units, and it was off the screen. So let's go back and put something in here. Let's say public float max height equals 10. And so inside of here, we will say something like if position dot y is greater than or equal to max height, then we're off the screen. We can get rid of this thing. So we will say destroy object, game object. And remember, this is little game object, little g, lowercase g. Now let's see what happens. If we run, it goes up, and then it disappears. All right, so let's watch it again over on the left, over here. Goes up, then it disappears. So it's getting deleted from our scene, because once it goes off the top, we have absolutely no use for it at all. All right, so let's see, what else do we have now? We have all of this stuff is working, and we need to wire it up to our spacebar. So our player controller right here is doing the shoot command, and it needs to know what it's supposed to do. And so let's say we need to have a public game object. We'll call it missile. And this thing inside of shoot is going to need to create an additional one of those things. So if we save it and look at our player, now we have a missile game object that we can instantiate. This thing is already in our scene, and that's not what we want. We want to be able to take one of these prefabs here and create a new one because we don't want to just keep reusing the one in the scene. So I'm going to delete this thing. And in our player, we want it to instantiate one of our missile prefabs. This thing. So there is a huge difference between dragging one over here from the left and dragging one over here from assets. So make sure that you understand that you're going to create a new one, so you want to use one of these prefabs down here, not something that you've already added to your scene. The reason we put the missile in the scene to begin with is because we wanted to be able to see the behavior of what it's going to do when we create it, and it makes it a little bit easier to troubleshoot that sort of stuff. But now that we know that as soon as it's created, it's just going to go in the up direction, which is what we want, we can just use this prefab here and delete it out of our hierarchy. All right, so let's see. Inside of shoot, what we need to do is instantiate. Let's see, what do we want to instantiate? Our game object, a missile. And the position is, let's just say transform.position, which is where we're at. And then it wants us to give a rotation, so we'll just say quaternion.identity. Okay, so we're going to instantiate a missile right where our character is. Remember, this transform.position is the position, the object that's attached to the script, which is our player, a little frog with a spinning hat. And the rotation of this object when we instantiate it, we just want to leave it alone. Leave it at the identity. And let's see what happens. There we go. So now I'm shooting as quickly as I can press the spacebar. I'm shooting. Notice all these missile clones are getting deleted. They're getting created, getting deleted, and that is all very good. I don't know. I was going to say it looks a little weird, like maybe it needs to be coming up from the top of his hat or something like that, but so we could fix that. On second thought, it looks like it's okay. It's like he's throwing it up with his arms, so we'll just leave it alone. But for example, if you wanted the missile to start here, notice how it's starting down here, like in his lap. But if you wanted it to start up here, really all you need to change is this transform.position. This is saying where you want it to start at. So instead of transform.position, you could create a temporary variable of position, just like how we do here, and then say position.y plus equals 1 or something like that, however much you need to move it up by, and then use that position inside of the shoot. Actually, here, let's just do it. So when we shoot, transform.position, we'll say position.y plus equals, 0.2f, and then inside of here, we'll just say position. So now when we run, 0.2 probably wasn't enough. Let's see now. So now I added 1 to it, and now it's coming up here. And if I leave it at 0, it's not going to change it. It's going to come down from here. So, based on that, you can have it go wherever you want. And there's a few different ways to do it. Like, we're just hard coding numbers here, so I was showing you how you could change it. Sometimes what people do is they will create another game object that's a child of this game object and sort of place it where they want it to be. And then you just find the position of that thing, and that's where you instantiate it at. If you've got a gun, maybe you want to put it more to the right or more to the left. If you're shooting down, you want it more below you. It just sort of depends. But yeah, you can hard code numbers like I'm doing, which isn't necessarily the best. Or you could attach game objects as child and figure out where those things are, and then that's where you instantiate your stuff from. So, yeah, so that's that. Let's see, what else do we have here? This thing, I'm going to give this thing a rigid body because we're going to need to crash into these robots. And let's see, if I give this gravity scale a 0 and give it a 0 mass, I think that should make it behave just how it is right now. Yeah, there we go. So they're still behaving how they are. They do have a rigid body, though, which means we can use them in collisions. All right, so we need to detect when we collide with one of these things. So let's give this robot a box collider. And then I'm going to hit apply. And by doing that, it should have applied a box collider to all of our other robots, and it did. So that's really cool. I mean, we have one prefab that's in our scene. We make a change to it, hit apply, then it goes to all three of them. So it's not like we have to go through and make that change, add that box collider to each individual one. We just added it to one, hit apply, and then we're done. And if we look at this, I think we can see our little missiles are colliding in with these guys and sort of going in weird directions. And what we need to do right now is check and see when there's a collision. We need to see who we're colliding with. So let's take a look at our robot controller script. Let's put some code inside of there. And we will create a new function called, I think, yeah, we did, void on collision enter 2D, and we'll have a collision, I think it's collision 2D, like this, and we'll just do a debug.log collision. So on collision enter 2D, we have our collision 2D object being passed into it, so we know what the other thing is. Let's see if we actually detect it. Collision, collision, collision. So yeah, we're seeing collisions. There's been 6. Let's see if we can get some more up there and make sure that we know what we're doing. 7, 8, 9. Yeah, everything's working good. One of the problems, though, is that these guys could start to collide with each other, and then you'll see the collision counter going up even more. And the effect of our game is that we only want these guys we want them essentially to delete themselves or do something when the missile comes in contact with them. But if these two guys happen to accidentally collide with each other, we don't want them to blow up and go away. So I'm going to make sure that my missile has a tag. Right now it's untagged, so I will add a tag. We'll create a new one. We'll call it missile. And then we'll make sure that my missile is tagged with missile. And that's good. And then in our code, we can say something like if call.gameObject.tag equals missile, then we know we're colliding with a missile. And this is just going to be a good check to make sure we know that we're doing something correct. Collision with missile. And let's run it and see if that makes a difference. Collision with missile. Okay, good. So that was worthwhile. So now we know, all right, we're a robot. We've collided with a missile. What we can do is we need to destroy ourselves and also destroy the missile. We need to get rid of both of them. So in here we can say destroy object, call.gameObject, and then the other thing we can say is destroy object gameObject, which is destroy ourselves. So this is the missile, this is the robot. And if that's right, let's see what happens. There. So when I hit 1, the missile and the robot disappear. If I don't hit anything, my missiles go off the screen and get deleted. But yeah, it's pretty simple. I'll just even delete this debug. So when there's a collision, remember this is attached to our robot. So when there's a collision, we check to make sure that we've collided with a missile, and we have. And in that case, we will destroy the other game object involved in this collision, which is the missile, and then we will destroy ourselves, which is the robot. And we can start to do things like we can put multiple rows in here, like this. And I'm just doing Command D again to duplicate all these. And then as they're running back and forth, maybe I'll shoot some stuff on the bottom first, or depending on how it works, shoot them there. And there we go. So now we've got a pretty good framework for building this whole thing. We can make these guys smaller. We can make our missiles smaller. We could do all of that sort of stuff. I think one more thing that I want to do is let's play a little bit of an explosion when one of these things hits. And so to do that, we're just going to play, we're just going to instantiate a star and have it fade away. So that's going to be the whole point of our explosion. We could do smoke and particles and all sorts of fun stuff, but we're just going to show the star right where the collision takes place and then fade it out. So just like we did with the missile, we're going to first add this thing to our scene and write a script for the star. We need to make it bigger. That looks pretty good. That's going to, when it gets created, all it's going to do is fade out over time. That's it. So let's just rename this thing to explosion. Explosion. And let's make a script, and we will call it, star fade. And we will attach our star fade script to that, and we will also make an explosion prefab. Sure. I guess I haven't been good at saving recently. I don't know why it keeps telling us that. All right, so in our star fade script, the only thing that we want to do is over time we want to update our transparency of our star, starting it completely solid, and then over time make it completely transparent. And that's the whole idea that we want to get through. And hold on one second. Okay, yeah. And so that's the idea. And we need to know a couple things about this before we go. We need to know our starting transparency, our max transparency, our min transparency value. We need to know how long we're going to take to fade this thing out, and then we'll start working on it. So I'm going to make a couple variables: public float min. This is our min transparency value, which is just going to be 0, and public float max, which is just going to be a 1. The duration is, let's just say 5 seconds, or I'm sorry, half a second. That's how long it's going to take for the star to fade away. Oops. And what else do we need to know? Start time. So we need to know, we're going to record the time when this thing gets instantiated so that we always know how far away we are from when it got instantiated, so that when we do get to half a second later, that the object is completely transparent. So when this thing gets instantiated, and we will do the instantiate just like we did with creating the missile, inside of our robot controller, when we decide it's time to go away, we will do an instantiate on our explosion prefab, which as soon as that gets exploded, the start will get called, and we will set our time. So this will be start time equals time dot time. And again, this is the time that our particular star has been instantiated. And we're going to instantiate a star anytime there's an explosion. So that'll be that. So let's see where we're at. So we'll say float t equals 1.0f, where we started, minus time dot time, which is the current time, minus start time. How much time has actually elapsed since we started this thing, and then we're going to divide it by the duration. So basically, we're trying to get the the percentage of the way that we are through this transparency, and then we will set the color. So we can say game object dot get component. Oops. Get component. And we want to get the sprite renderer of this 2D sprite. And then we can say dot color equals new color. And we'll pass in there 1, 1, 1. So basically leaving all the RGB values the same. And then for our alpha, we are going to use a smooth step function. So we'll say math f.smooth step. And we're going to say our min, max, and our t, so our percentage essentially. And that is going to correctly set the transparency value. And that's all that's going to happen. So let's see if that actually works. So here we are. And it fades out. Notice that our explosion is still inside of here. We need to delete it from the scene. So we'll put one more if statement in here. We'll say something like if t is less than or equal to 0.01. So this is the actual transparency. We're starting from 1 and going all the way down. So if we're all the way down at the end, then we're okay. We can delete this star from the scene. So we'll say destroy game object. And this way we won't have leftover stuff. So we'll watch our explosion here fade away, and then it deleted itself out of here. All right, pretty cool. So this all seems to be working, and we just need to instantiate this explosion when our robot decides that he's been hit. So we will, did we make a prefab of explosion? Yeah, we did. So now that this thing is here, I'll just apply it. I can't remember when I did the scaling of it, but that's all right. And I will delete this from our scene like this. And inside of our script for our robot controller, let's add in public game object, and this will be an explosion. And so if we click on our robot controller, our explosion is now empty over here, but we do have an explosion prefab that we can stick right there. All right, and then right here when we're deleting everything, just before we delete ourselves, the last thing we want to do is instantiate an explosion at transform.position, right where we're at, because that's where we want to play our explosion animation, and quaternion dot identity, same rotation. All right, so this, again, this is inside of a robot controller. We've decided that a missile has hit us, so we're about ready to delete everything. We delete the missile, we instantiate our explosion, which is just going to show a star and fade away, and then we delete ourselves. And let's see, is that going to work? Oh, errors. Doesn't know what instantiate is. Would help if I could spell. Okay, things are going. There we go. So now wherever we hit, it's going to show a star and fade it away. Let's see if I can get this last one. There it goes. And notice this is all clean over here on the left. When something is not in our scene, it is not here. And that's how we want it to be. All right. Let's see. You know what? One more thing. Let's just do one more little thing before we're done with this. And you know, we did in Angry Birds, or whatever we call it, Happy Bears, we kept track of how many enemies were in the scene and kept track of them as they got deleted. And then we knew when they were all gone, we could switch to the next scene. And we can still do all that inside of here, but we don't need to replicate any of that. So if you're interested in knowing about, how to determine when all these enemies have been killed, follow the example we did in Happy Bears, which is, I think, the video before this, or maybe 2 videos before this. But that'll help you figure out how to move on to the next level. But one more thing I want to do, I want to rotate this little star. You can do little things to make it a little bit fancy. I mean, the fade out is kind of cool, but we could also just give it a little bit of a rotation to it. So in my star fade, I'm going to do a rotation. And so rotations are in quaternions, so we'll say quaternion q equals transform dot rotation like this, and we will say q dot z. This is the one, the z value is what's going to allow us to rotate it side to side, equals math f dot smooth step. And we will just give it our min and our max. Again, 0 and 1. We're using it for both the color and the rotation. That's fine. Just something to give it a little bit of movement. And then we'll say transform dot rotation equals Q. And those 2 or 3 lines of code here should just give it a little bit of a twist. Let's see what happens. There it goes. Yeah, so it's just a little, you don't need to have that kind of stuff, but it makes it look a little bit more exciting. It's only a couple lines of code. It's not really, dragging on the CPU that much. But that's that. So I think that is what I wanted to show for the single screen shooter. Again, we brought in the graphics. We created a controller to handle all of these guys. Created a whole bunch of prefabs. Did some tweaking over local scale in order to make it look like we're moving left and right. We learned how to instantiate objects on the fly, create prefabs that have actions associated with them, such as moving up or fading out or rotating. And we gave some code to do some autonomous movement of these guys. And we can start putting this together with what we did with Angry Birds to start building longer games, more complex games. So I think that is all I want to do for this one, and we'll